Okay, so my cut was not very good, but there's the question. So when I'm doing these, there are a couple of different ways to do it. I think I've only sort of gone over the one way, and you and I talked about it a little bit with an equal or with an equality before, that you were comfortable subtracting this over and working kind of a single fraction on the other side anyways. I think that's the best way to do this question. So I'll go ahead and get it started. If you see something that doesn't look quite right, you can let me know. Either that you think I got it wrong, or that you see sort of where things got confused. So I have negative x plus 5, and I'm going to subtract this whole thing over. And it'll be less than 0. The reason I like this as opposed to, I don't know if you looked in the book, but they have kind of a situation where they set up a case study and say this could be less than 0 or greater than 0, and so could this, and to me it gets just a bit messy, so this is the one I like anyways. So that means I'll have a common denominator of x plus 3 on this side. So I essentially need to write this section here over x plus 3. And so I'm going to treat it as a single piece, although I could do it separately as well. It doesn't really change things. And so this is going to be the common denominator. I need to multiply the top obviously by that as well. And now I'll expand the top here, and then I'll have a single fraction. So this is negative x squared. I'm going to have minus 3x plus 5x, so plus 2x, plus the 15, and then minus the 1, all over x plus 3. Okay, so if anything there wasn't okay, don't hesitate to stop me, but I know you're sort of pretty comfortable with this part of the work. And so sometimes I write out more steps when... Okay, give me a sec. There's something going on in the hall that I think I should check into. Just hang on 1 second. Okay, apparently there's nothing going on in the hall as far as I can tell, or so you don't have to put the x plus 3 with the 1 on top. You're saying an x plus 3 up here? No. What I'm doing here, okay, so let's, I'll back it up, and so let's say I had something just with regular fractions here. Okay. If I was looking to add this, I'm essentially saying I have to rewrite negative 5 with the denominator that the other one has. Okay, so then it's going to be negative 5 times 3 over 3 plus the 1/3. Okay, so if you ever sort of get hung up on something like that, always go back to a nice easy question, or easy for you sort of thing, that looks similar. I've got a number here. It might be negative, it might be positive. I'm not too concerned about that. I don't know what it is, but again, this would just be some number. And so this is a number. I have minus, which doesn't really affect things, I guess. I could have made it a subtraction. And then some fraction, 1 over something else. Well, here I have 1 over something else. And so what I'm going to do, I have to find the common denominator, multiply numerator and denominator by that same value to get negative 15/3, which then allows me to simplify the top and kind of combine into one big fraction. Okay, so essentially the same thing here now. The fact that there are x's involved doesn't really change again, this is a number of some sort, and this is a number of some sort. I multiply this by the number from the bottom of the other fraction. Okay, and that is less than 0. And so now I'm looking for sort of the key areas where I'm going to have either a problem or specifically I'm going to have a 0 here. The top is a little bit messy because of the negative sign. It's not a huge deal, but the negative might throw me off a touch. So I think for this one, what I would like to do is, if I had x squared plus or minus some number of x plus or minus some value, kind of a standard trinomial here, I'd feel more comfortable factoring it. So this might even be where people would have got hung up more than others. I would factor out the negative sign here, just because I don't like it. And that would leave me with minus 2x. And that would leave me with minus 14. Another interesting one. That doesn't look like it's going to factor for me, does it? I'll slide back up and just take a peek at what it thinks I'm going to get. Oh yeah, okay. I guess that makes sense. Okay, I thought it was going to factor, but it turns out it's not. So this step actually kind of unnecessary because I'm going to have to use the quadratic formula to simplify. Like I said, I sort of assumed that I would be able to factor, but it turns out I can't. So what I'm interested in, again, are zeros in the numerator and zeros in the denominator. The zeros in the numerator will give me those key points. I'm looking for values that are less than 0 here, so I kind of need to know where are things 0, and then one side of it will be negative, one side of it will be positive most likely. My graph is kind of going through the 0 at certain points. Those are the points I'm interested in. And then zeros in the denominator, of course, because that gives me an asymptote and something that obviously can change the graph substantially at that point as well. So with the numerator now, I'm going to do a negative b plus or minus, all that jazz. And I guess what I'll ask here is, can I assume you got to that point okay? If you're saying that the signs were mixed up, did you actually use the quadratic formula and find those two numbers? You got those ones? Okay, so if you don't mind, I'm just going to pull those numbers and use them. I don't think there's any reason for you to watch me write out the quadratic formula and the numbers, only to then decide that the numbers in the book and the numbers you got are right. So negative, actually I'll just pull this down so I can copy them down. And then we'll just do the line chart that's going to help us get the final answer. So it looks like up to this point everything is correct. It's certainly leading me to potentially the answers that are here. The key points, the negative 3, in case you missed it, is from here.
Please excuse this interruption. Would the next group please go for their photos? In room 227, Cody Loach, Colin McKinnon, Kerrigan Nickel, Rebecca Joy, Joy Panasoon, Zoe Dano, Matthew Burchett, Brooke Mercer, Alex Valleycat, to room 227 now. Thank you.
Okay, so x cannot be negative 3, of course, because the denominator then gives me a division by 0. So these are sort of the key points. These are my zeros. My graph is either going to go up through those or down through those. This one, sorry. And then this one is going to be an asymptote. So I could be positive on one side and negative on the other. So essentially I've got, what, 1, 2, 3, 4 sections that I need to test. And so all I'm really going to do now is plug in a number that's in this area, -4, -5, something like that, and determine whether I get a positive or a negative value. And I think, didn't mean to do that. Let's clone it here. No, I'm lying. I think this is actually the nicest part of the question to work at. So since I have this factored section, I might as well go ahead and use it. So I'm putting in a number like -4, and essentially I'm interested in whether the numerator and denominator are positive or negative, and of course overall. -4 in my denominator makes my denominator negative. -4 plus 3 is -1. Up here, I would have 14. -4 would be plus 8. So 14, sorry. 16. -4 squared is 16. Plus 8. So essentially this part is positive, but there's a negative out front. So I'd have negative, and then my bracket would be positive. Overall, okay, I'm getting, I think, what you're saying, that overall this section I'm reading as being positive. Maybe we should have just graphed it. I would have found out that, so I think this is what you're telling me, that you got these same numbers, but you found that this section was positive, and probably the same thing over here, and it looks like that's where I'm headed to. Something like -2.9 now. -2.9 would give me a positive number in the denominator. And up top here, that's positive. -2.9 times this would be positive as well. But that would be, let's see, slightly below 9, slightly below 6, 2.9, slightly below, so that would be slightly positive? I'm not sure. I gotta find a calculator here. But I think we're on the right track anyways, eh? So yeah, this would be, oh, sorry, wrong number. It's a plus sign. Yeah, so this is ever so slightly positive, which means that overall this section is negative. And then of course we know this is going to be positive and this is going to be negative, so I would say you were absolutely right. Big number in here, 5, 5, yeah, positive, positive, and negative. Number like, well, 0 I guess would work here. I get -14, and that becomes positive in there. So yes, you are absolutely right. The answers you actually wanted here, -3 less than x less than -2.873, or x is greater than 4.873. Sometimes I think I'm stupid. I started by saying, did you just verify using Desmos? And then I thought we could just verify using Desmos and see if all your numbers look right, and we just had, again, the book mistyped it, or basically the book just kind of put in the solutions to greater than 0. And then I thought, sure, we could just go through the whole question instead of just looking at it quickly. Because I am an idiot. But it looks like you did perfectly. As is the case most of the time when you ask questions, I guess. But